In terms of how the lake's formed through a mixture of sort of karstic or limestone weathering processes, forming deep cave systems, and repeated series of being flooded and then exposed by sea level change over the Holocene. So the Holocene's the last 10,000 years. They have a lot of biodiversity values. There's important vegetation which fringes the lake. There's also water birds that use the lake that are Ramsar listed and rare and endangered. In terms of the microbialites themselves and the microbial mats are important because each community of microbial mats all around the world is unique. There will be dozens to maybe even as many as 100 different species of bacteria, cyanobacteria and archaea that are present in these microbial mats. And the way they interact is it's almost as though they form their own little ecosystem within the microbial mat. Why are they important? Well, these microbial mats in particular, along with a number of other communities around southwest Western Australia, form microbialites. And microbialites are basically limestone deposits that result from the presence of these microbial mats. And we don't actually understand exactly how the microbial mats form this limestone, but we know that they're responsible for it because we always find active microbial mats in areas where limestone is currently forming. They're important for lots of reasons, but I guess one of the most important reasons is that if you go back to sort of 2.5 to 3 billion years ago, when life really began on Earth, these microbial mats were effectively the closest modern analog of them. They basically were very much involved in colonizing the planet, producing oxygen and other types of compounds through their biological activities that allowed higher, more evolved forms of life to come afterwards, like ourselves. And yeah, I think it's amazing that a form of life which was here at the origins of life has more or less persisted through 2.5 to 3 billion years. It's still here today. And so there are very, very few sites around the world with active microbial mats forming microbialites. They're scattered all around the world, but here in southwest Western Australia we have an abundance of sites, more so than anywhere else in the world by a long way. From Shark Bay all the way down to Pink Lake and Esperance, there's microbialite deposits dotted through a number of these coastal wetlands. The early Earth was very nutrient poor. There was very, very few nutrients around in the environment like there are now. In fact, these days we probably have too many nutrients floating around in the environment. That's why we have algal blooms in our wetlands and our rivers. But back in the Archean, in really early period of Earth's history, there was almost no nutrients. So these life forms evolved to utilize conditions that were nutrient poor. Most higher life forms that have come after them can't actually adapt to living in those conditions as well. So the presence of these microbialites in just a few lakes is because I guess they are naturally nutrient poor systems that no other life form can inhabit. And the expression I use for nature is nature abhors a vacuum. And so generally if there's an area where there's some resources that a biological entity can capitalize on, something will evolve or something will colonize it. And that's the case here, where these systems are naturally very saline and they're naturally very nutrient poor. So for normal blue-green algae, very, very hard for it to live there. In fact, it can't. But these microbial mats are actually able to somewhat regulate their own environment like corals do. Corals are microbial communities effectively that use the calcium carbonate of the coral as well as some internal processes to sort of buffer the impacts of external change. And microbial mats do the same thing in this context as well. So it's the lack of nutrients, the lack of other organisms that can compete with them, as well as actually the lack of other organisms that can eat them because of the really sort of harsh nature of these systems. And one of the biggest threats to microbialites comes in water quality change. As you can well imagine, it's this sort of magic area where if it gets too much more salty, nothing can live. If it gets less salty, other stuff can come in and compete with them. So it's a real balance of getting the hydrology of these systems right in terms of making sure they don't get too salty or less salty or end up with more nutrients in them, because more nutrients in the environment mean that other organisms will be able to compete with them again. In a microbial mat, you have 3 layers. Lower sulfur reducing bacterial layer, the purple layer, and then above that you'll probably have a green layer, which is where the photosynthesizers are, and then on the top of that you'll probably have an orange sort of like a white sort of mat, and that can be a mixture of things. Sometimes the green and the orange mat can be sort of flipped around, but the sulfate reducers are always at the bottom, the SRBs. they live off each other, and it's an ecosystem in its own right. And the work that we've done on looking at the DNA of these communities to try and get to a species level identification suggests that each of these mats might have 30, 40, 50 different species in it, and as I said before, a mixture of cyanobacteria, bacteria, and archaea. There's a lot of mat present in these Rottnest lakes. I've been completely blown away by how much mat there is compared to some of these other sites that I look at. Very, very impressive community.